Okay. Since this is a really intimate setting, if there's any questions or anything is confusing, feel free to stop me. I can kind of flow through this and skip around also if there's things that you want me to go back to, or if there's anything that is like that you already kind of know. I'm Arjun. I'm one of the founders of Everclear. We were previously known as Connext, which you might have heard of. Connext was one of the first intent-based bridges. We also have done a bunch of other stuff in this space. We've been around since 2017, which is a very, very long time. With Everclear, we've sort of taken a little bit of a new direction, centered around some of the problems that we've faced around building an intent-based bridge. And as you may know, most bridges today are heading towards becoming intent-based. And they're doing this because it's just really a fantastic model, and because they want to kind of address the big boogeyman that everybody is talking about now, which is fragmentation. Right? Fragmentation is the biggest problem with this space today. We've successfully managed to scale blockchains and commoditize block space, but it's come at the cost of just this awful experience. And you can see how over time, TVL that is on other chains is generally just moved further and further away from Ethereum, and in a way that's completely difficult to reconcile, with the minor exception of that blip in 2022, which is Terra, of course. May she rest in peace. And this is getting worse. According to L2Beat, there are 61 live layer 2s on Ethereum today. Isn't that crazy? 61. I actually had no idea until I looked at this. 61 live layer 2s. So obviously, a lot of them have very, very little capital on them, but there's still a lot of layer 2s. And then there are 79 upcoming L2s that are registered on L2Beat. And this number is very, very much lowballing it. So I've over the course of this week, I've been talking to folks like Gelato, AltLayer, and others, and they all say they are independently expecting to deploy, have a pipeline of hundreds that they expect to deploy before the end of the year. So this problem is going to get very bad very quickly, and there really isn't an answer right now, right? And so this space and overall, everybody's been talking about chain abstraction as the theoretical answer to this. Chain abstraction is something that we, as Connext, first kind of started to pioneer last year. We were started to talk about this idea of or this vision that as a user, you should never have to care about what chain you're on. Not necessarily a totally revolutionary idea, but it has been a really awesome shelling point for a lot of projects to start being well, how can we build towards this outcome, right? How can we create this experience where, as a user, you never really have to think about the chain that you're using, right? How can we make it possible to have app chains where you just go and use the app chain and that's it? And our hypothesis at Connext last year, when we introduced this, was that this can happen using intents. Now, I assume because it's been the hot topic in Brussels that all of you have heard about intent so far, correct? Is anyone still confused about it? No, good, thank God. I normally kind of give this overview of how intents work, using Uber as an example, but I'll just kind of skip ahead a little bit and talk a little bit about what this stack is starting to look like, right? And if you kind of think of Uber as an intent protocol where you're kind of creating your intent to go to another place, and then Uber is matching you with a driver and then solving your intent because your driver solves your intent by driving you to the place, you can make a almost one-to-one comparison to what is happening in this chain abstraction stack, where at the permissioning layer, within your smart wallet or something like that, you're expressing your desire to do something, and you're giving access to an application to do the thing for you. And then you have an auction, an order flow auction, where a solver, a service provider, is selected for you that can most effectively fulfill whatever it is that is in your truest heart's desire. And then you have the solving step. So this is your Uber driver actually drives you to where you need to go. And then lastly, once that's done, you have settlement, which means the solver goes and makes the transaction for you, and then everything after the fact, they kind of figure out how to reconcile that transaction against the chain. Okay. There's obviously a lot of projects kind of building towards this outcome today. But there's still something missing, and I think that this is something that a lot of people are starting to kind of realize today, but it's still a relatively new concept, which is that solving is a little bit of a hand-wavy thing at the moment, where all of these projects are saying, okay, well, solvers this hypothetical market will come and fix all of these problems for us, right? We as users can push all of our complexity over to solvers, and solvers will deal with it on our behalf. But in practice, this is not what's actually happening. In practice, the vast majority of solving that's happening today, and this is specifically for like trade execution because it's like the most like initially focused intent use case, the vast majority of solving that's happening today is happening through a few large sophisticated players. And so this is a diagram that shows the kind of distribution of order flow for across in DLN, and you can see like almost all of it is flowing through just a few folks rather than like spread out evenly over a large number of solvers. And the topology of solvers looks kind of like this, right? So you can imagine like over here you have high TVL, over here you have low TVL, and that vertical y-axis is like the amount of fees that you're earning from solving. And you can see how like Wintermute, as a very sophisticated player, is like all the way on this side because they have they have effectively infinite amounts of money, and they are earning infinite amount of fees as a result of it. And then you, the scrub that you are, unfortunately, are all the way out here. There's no real way for you to compete. What should this look like? Well, ideally, you should be earning revenue proportional to the amount of liquidity that you have, right? So it should just be like fixed APY, regardless of whether you're providing like $10, $1,000, or $10,000, or $100 million. And that's kind of what we need to get to. We need a straight line that's kind of going across like this. So how do we get there? Well, to answer that question, I think it's important to first understand, why are we in this place in the first place, right? Why do we have these like enormous power law associated with solving, especially for large actors like Wintermute? And the answer to this is that this piece, like if you kind of think of the intent flow, right? User deposits into Aave across chains. You go and you say, I want to deposit 10K into Aave on Arbitrum, and you express this to an intent protocol, and a solver goes and deposits the 10K into Arbitrum for you. The problem that I think nobody's really thinking about today is what happens afterwards. So how does that solver actually get repaid? Well, in current intent systems, and really this kind of makes sense, right? In current intent systems, the solver is giving liquidity, 10K on Arbitrum, and they're getting your liquidity, unlocking your liquidity from the source chain. So naturally, their capital is moving, right? They've given liquidity on Arbitrum, they're getting liquidity somewhere else. If you're coming from degen chain, they're getting liquidity on degen chain, which really sucks. And so over time, this necessitates rebalancing, right? Solvers have to continually move their capital back to where it can be used. Rebalancing is difficult because it requires a solver to have to like think about, how do I get my capital from degen chain back to Arbitrum as efficiently as possible in a way where I'm not having to wait 7 days for an exit window, because that's of course like not capital efficient, and in a way where I'm not having to pay tons and tons of money to do it, and also in a way where I'm not having to like learn a lot about each different ecosystem I support. Because of course, like if you're a solver that wants to support bridging into Arbitrum from any chain, that means you have to figure out how to get out of every single chain, which is insane, right? It's an insane proposition, especially when we're talking about thousands of rollups. Now, the interesting thing about this is like when you go and you talk to solvers, how do they do it today? Well, the ones that are doing it, they basically are using bridges or they're working with market makers. You go and you talk to the market makers and you ask them, how are you guys doing this? And they say, oh, well, we're using the centralized exchanges. And you go and you talk to the centralized exchanges and you ask them, how are you doing this? And they're saying, well, we've hired a team of like 20 people. And what they do is sit and on the Arbitrum UI and just press the button on the 7-day exit. And they just do this, like, and they don't charge anything for it. They just eat the cost of this because, like, they don't really understand how to solve this problem, and everybody's dealing with it. And so ultimately, it's all fragmentation, right? Like, we have this fundamental bottleneck in the space, which is if you want secure messaging between chains, that takes time and costs money. And if it takes time and it costs money, then that means that there's going to be liquidity fragmentation, because that means there's going to be some amount of time where you need people to be locking up their capital. So instead of having everybody go and lock up their capital, a question that we started to ask ourselves was like, well, how much capital do you actually need to lock up? And this is where you get some really interesting answers, which is on average, 80% of the flows that happen between chains today on a day-to-day basis net out, which basically means like every time you send $1 into BNB chain, 85 cents comes out. So that naturally begs the question, why are you sending $1 into BNB chain? Why don't you just send 15 cents, right? Like, why are we doing all of these back and forth transactions? And this is this is an interesting question because there's like very direct parallels to traditional finance. And in traditional finance, the way that we solve this problem is with something called netting, where you take a large number of like financial obligations or relationships that a bunch of people have with each other, and then you translate them down into a final sum. Right, so you're taking $420 worth of transactions over here, and you're turning it into a kind of final $10 transaction. I tried to make the numbers work out so it's 420 and 69, but unfortunately didn't have the time. And there's a lot of parallels to this in other places too. So have any of you used Splitwise as an application? Nice, yeah. Splitwise is basically netting, right? Splitwise is an app where if you go on a holiday with your friends and one of your friends pays for dinner, one of your friends pays for tickets, and whatever, you all kind of owe each other. You have this network of financial obligations, or this graph of financial obligations to each other. And instead of having to pay each other every single time someone does something, you just register these obligations in Splitwise. And at the end of the trip, Splitwise just says, how much does everyone actually owe each other? And usually that's a lot lower than the total amount of transactions you would have had to do. So to harness this, we want to introduce a new primitive to the space. A new primitive that we're calling a clearing layer. Clearing in finance is a process, basically everything that happens between transaction execution, so when an intent gets solved, and settlement, which is where everybody gets repaid and everyone ends up back in the position where they were, where they can continue doing more transactions. For example, for Visa, Visa is technically a clearinghouse, right? It's a payment clearinghouse. Visa, when you pay with a credit card, Visa authorizes your transaction, which means that they immediately tell the merchant, hey, this transaction should go through. They're basically filling your intent. And then behind the scenes, what Visa is doing is they're taking all of the transactions that have happened over the course of the entire day or every 12 hours or so. They're netting them all down. And then they're providing a final list of settlement instructions to the banks that they're working with. We kind of want to do something similar, where rather than having a bunch of bridges, a bunch of liquidity providers, a bunch of market makers, centralized exchanges having to go and have independent relationships with bridges or basically with liquidity on their own. Instead, we allow them to coordinate with one another, right? So if Alice is a solver that has been filling transactions going from Polygon to Arbitrum, and I'm a solver that's going from Arbitrum to Polygon, instead of both of us having to rebalance, we can just net off against one another. So neither of us have to do it to begin with. Now, all of a sudden, you've turned the cost basis of rebalancing from Arbitrum to Polygon, which would, of course, be a lot of money since you have to go through the 7-day exit or whatever, down to effectively zero, because it happens instantly and just in a coincidence of once with another person. This is sort of like we sort of seen in this space that every solution to liquidity fragmentation so far has involved basically building another bridge or creating another system that requires liquidity, right? And what that's effectively done is actually proliferate fragmentation, right? It's made this worse. If there was one bridge, we would be fine. We wouldn't have this problem. If there was one token standard, we would be fine. We wouldn't have this problem. But there aren't. There's more. And the more standards there are, the more bridges there are, the worse that this is getting. And so we're kind of ended up in the worst outcome. And so rather than trying to build another bridge, rather than trying to create another system that looks exactly the same, we said, let's find a way to get existing systems to coordinate. Now, how does this work in practice? Everclear is a rollup. It is basically, the job of the rollup is just to compute the optimal settlement for every participant. So if you're a user of the system, you can almost think of it like a slow, very slow, but extremely efficient bridge. If you're a user of the system, you are, as an intent protocol or a solver or market maker, you're depositing into the system. And when you do this, the system purchases your deposit effectively by issuing an invoice. An invoice here being an IOU from the protocol back to the user. And then what the system does is it attempts to settle, it basically puts all invoices into a queue, and attempts to settle invoices every epoch, which is every 30 to 60 minutes, by settling them against available liquidity on each chain that it owns. And it can, of course, do this on a one-to-one basis. That's where the netting piece comes in, right? So if I have 100K of liquidity on Arbitrum, and then there's a 10K invoice that is okay with being to settle to Arbitrum or Polygon or ZK Sync, then I can instantly settle it to Arbitrum using that 10K of liquidity. And then it kind of goes through that queue, and everything that's remaining is, once it kind of runs out of liquidity, there's, of course, going to be some invoices that are remaining. And anything that is remaining is decremented in price. So it gets a little bit cheaper, so there's now an incentive to arbitrage it, and it gets pushed back into the queue for the next epoch, which is, of course, a Dutch auction. Everclear and clearing sits at the base of the chain abstraction stack that we talked about earlier, right? So if you are a solver, Everclear is basically making it possible for you to go and fill more intents more quickly, and so the system is effectively powering all of the work that happens above it, right? Without having this mechanism for clearing, solvers are not able to go and have sufficient liquidity to be able to make these transactions happen as effectively and as they want, or even on like the number of chains that they want to, right? They can only really work with the like most popular chains where they have the deepest liquidity. And without solvers, you can't really have auctions that are competitive for every single ecosystem. Without auctions, you can't really have apps that work with every single chain. And so we kind of see this as like a fundamental piece that needs to exist in order for the rest of the chain abstraction vision to even work. And this is part of a larger transition that we're kind of seeing in the space, right? So like we've made this really awesome transition from like monolithic blockchain structures to modular. And this transition is how we have scaled, right? By modularizing blockchains, we have been able to like horizontally scale execution, which gives us infinite block space. What we do with that infinite block space, still a bit of an open question, but that infinite block space doesn't really matter unless users are able to use it. And so what we're seeing is that there's this like secondary transition that's starting to happen now, where the modular stack is being complemented by this secondary stack that's being built on top, right? The modular stack is sort of this like scaling backend, and then you have this abstraction stack that's being built as the front end to it, or as it's frequently called in like scientific papers and academic circles, the modular monolith. We've been working on this set of problems for almost a decade. And by we, I mean collectively this space, right? I joined this space back in 2016, and the problems we were talking about then were like, how do we scale blockchains? How do we abstract away gas? How do we abstract away accounts? My first project in the space was actually like gas and account abstraction. And then like as part of that, like if we are working with other chains, which at the time was like sidechains, how do we make it easy for people to use these sidechains? We haven't really like gotten very far in terms of like the core problems that we're solving, right? So and that can be a little bit disheartening because you're like, well, will we ever get out of there? But it's interesting because like we have made a lot of progress technologically, and what that implies to me is that there is a single shared set of problems here. There's like a single trade-off space associated with scaling and user experience, and that single trade-off space is what we've been circling around for a really long time. For the first time in almost a decade, it feels like we are actually close to solving that trade-off space, right? It feels like we are at the cusp of getting to the point where you can have this outcome, right? You can allow for people to build blockchain-based applications that can scale infinitely, and that can be used from anywhere in a way where users never really even need to know or care that they're using a blockchain-based app. For me, I'm personally super excited by that because I joined this space not to make it easier for people to build blockchains, but to go build cool stuff on blockchains, right? And that's, I'm sure, what everybody else here feels as well, where you're like, all of this infra stuff is cool, but I would like to get to the next step. And I think that that's where we stand today. It's like if we are able to kind of get to this point where we abstract every chain, we can go and build the really incredible use cases, right? Like mutual credit systems, entirely new monetary systems, like peer-to-peer insurance and lending mechanisms, like decentralized Wikipedia, decentralized AI. We are almost there, and that's what I personally find super exciting. That's kind of what Everclear is doing in a nutshell. So if you are interested in these topics, in clearing or intents, and chain abstraction, and in kind of some of the more interesting aspects of application-specific blockchains, come talk to us. We're trying to find folks that are passionate about these ideas and try to support them as much as possible. Questions? Yes.
Is that similar?
Yeah, so cycles, so it's really awesome that clearing is starting to get more recognition as like a concept financially. I'm a huge fan of Ethan's work. We actually have met each other for the first time a couple of days ago and like spent like 3 hours walking around talking about clearing and a bunch of other stuff. We're very similar people, which is really awesome. I would say Everclear and Cycles are slightly different in the fact that we sort of have different targets, right? So like Cycles is trying to take existing credit obligations that are out there in the world and find ways to like optimally settle them because those credit obligations are much, much more complex. Whereas Everclear is specifically focused on one problem within the space, which is like clearing between chains. The Everclear model is not going to work for what Cycles is doing, and the Cycles model is not going to work for what Everclear is doing. So I would say like, maybe to answer your question, like we're different projects targeting different things, but related in the fact that we're thinking about this problem in the same way. It's like the same solution to two different problems. Same mathematical solution. Yeah, it's the same sort of like, trying to think of a good example here. It's sort of like how you could use like ZK for scaling and also for privacy, right? And technically speaking, the way that you're using ZK is slightly different in both cases, but you can use it for both.
Why is it not the same solution? I mean, that implies what you're saying implies that the definition measure is different.
Yeah.
Your technical implementation, but like you're saying text.
Yes.
So what's different about it?
Yeah, it's a really, really good question. So I'm smiling because it's something that I've actually spent a lot of time thinking about as well. Because like originally when I was designing this, like when we were kind of like thinking through the original design of this, a lot of it was centered around basically the type of clearing that Ethan is interested in, which is like n-party graph traversal, right? So like in cycles, what Ethan is doing is like plotting out a graph of relationships, which can be many like chains or loops or other like a more complex relationship of obligations, and then map reducing that but basically reducing that graph down to like a subset that is that effectively still represents the relationships, but is not like doesn't need to cost as much, right? In our case, it's a hub and spoke system. So there isn't a very complex graph of relationships. The topology is actually very, very simple. What we're doing is effectively being like a central clearing party, right? Where like our rollup, because, I mean, of course, rollups, like, so this is the interesting thing about blockchains versus peer-to-peer systems, right? Peer-to-peer systems are like points on a graph, they're points on a relationship, whereas blockchain systems are like consensus systems, so there's like a hub, a central state store. In our case, because we're dealing with chains, it is possible for us to build direct relationships from the Everclear rollup to other chains. And so the clearing process is way easier, right? We don't need to go and traverse a graph that goes from like, Arbitrum to Ethereum to Cosmos to whatever in order to clear that. We can just take relationships from Ethereum to Cosmos and we can net them off against one another. So I hope that kind of helps answer a little bit, but it's basically like a different way to think about this.
Okay, so he's the graph method is you got to go out to hunt for stuff. You're actually you got a ledger writing each debt.
Exactly. It's like we are the counterparty to everybody's obligations, whereas in Ethan's system, there are existing counterparties to obligations, and you are traversing across those counterparties and reducing those obligations. Yeah.
Follow-up question then. Have you mapped out your words and obviously updated them? So you mapped out the words and put a hierarchy to it in terms of because the clearinghouses are new words to us in this industry. Right?
Yeah.
And have you created some kind of structure to relate the words?
Relate, you mean like clearing in the sense of what Ethan means versus what we mean?
Just your understanding of these words and then of other words that might be important in this space. I'm just kind of curious because
Yeah.
I'd love to peek into your brain, but this is the next best thing.
Yeah. I mean, I guess if I'm understanding your question correctly, basically it seems like you're asking, have we thought about like the ways in which those traditionally defined financial terms relate to this space and their importance in this space? Yeah, it's interesting. So it's like clearing is a concept that exists in more mature financial systems. Now, the form that it takes is quite different depending on which system you're looking at, right? Like credit clearing obligations has been something that's been around for a really, really long time, and like there's just a lot of different approaches to it. But the core definition still kind of means the same thing, which is like taking like executed financial obligations and then settling them, like everything that happens between those two steps. And so I think like the fact that we are seeing a need for clearing in this space is a sign of the space's maturity. And it basically means we are kind of getting to the point where like, okay, they're like generally speaking, when I've talked to people about this, most people are like, oh, that's awesome. And then they're like, holy shit, why haven't we thought of this before? And then they're like, oh, I guess the space was probably not ready for it until relatively recently. And all three of those statements are true, where it's like, we would not have been able to do this a year ago. And that's not just because of technological limitations, but because there just wasn't enough flows going across chains that were canceling out. Right, we've sort of hit this like inflection point of maturity where it's needed. Where as we get more fragmented, there is a more and more of a need to have this. So that's, I guess, like I hope that helps to answer. Like that's like our hierarchy of words here is that like we've sort of been building around these terms of like bridging and cross chain and things like that. But what we're seeing is that like everything is modularizing, and when we say modularizing, we mean like teams are starting to solve very specific problems. So rather than solving cross-chain as this big hairy problem, they're saying we're going to solve how do you get a message from point A to point B, and then we're going to solve how do you secure that message, and then we're going to solve how do you make that fast and cheap. And so from our side, we're sort of seeing like, okay, well, when everybody was self-selecting into these problems, into these modules, nobody realized that this was needed. And generally, from talking to every like bridge and intent project, everyone needs it. It's kind of fascinating.
Yeah.
Hope that helps.
Yeah. Would you be interested in mapping out your words at some point, or?
Yeah, I would love to. I'll talk to you about it after. Yeah. Any other questions?
So, like clearing everything would be financial in nature, right? Like all use cases would be financial, and like, would you guys like you just wouldn't be concerned with things like function calls or something like that at all? It just would be all proof of transfer.
So yeah, that's a really good question. This system is specifically designed around order flow. So like this system is specifically an order flow clearing mechanism. So it's targeting like order flow of intents, and like generally speaking, the intent-based model kind of relies on like transfers of value at the moment to be secure. And generally speaking, of course, that's like the vast majority of the use cases on blockchains. Now, block space clearing also exists, right? You can, and basically what this means is you're taking block space that is coming from a bunch of different like chains, and then smushing it all together, and then finding like a shared outcome for all of them, which you can kind of, yeah. I would say it's sort of like it's unclear to me whether that's like shared sequencing or more like Aglair, but it's something that I'm trying to like understand a bit better right now. I think Sam Hart has actually done a lot of really good thinking on this, so he would be the authority to ask.